All right, in 8.1.5, we're going to talk about more rotations, and we are not just going to rotate around the x or the y axis this time. We're going to be rotating around different axes. I especially like this one because they don't know what a tangent line is. So, we are going to take this area and we're going to rotate that around the x-axis, the y-axis. Y equals -1 and x equals 3. And we're going to find out that these last two in particular are a little bit unique. So we're going to follow these directions by roughly drawing a sketch. We're going to talk about what the slice is. We're going to either do disks or washers. We're going to write an integral, and then we're going to evaluate the integral. So this first one here, we're going to rotate around the x-axis. Now let's go ahead and draw that. So we'll have the x-axis here. We'll draw it being rotated here. And we'll talk about a typical slice. So a typical slice of this may look like this. We have a big circle. We're going to subtract the inner circle. So that means we're going to be using the washer method. And since we're using the washer method, we are going to talk about vertical slices. And vertical slices are just going to be the integral of our two equations. The equations that we have is y equals 4, and the other equation is y equals x squared. So we need to determine which one is going to be our outer function and which one is going to be our inner function. Our outer function is going to have a radius of y equals 4. So that's going to be our first one. We're going to go from 0 to 2, by the way. So from 0 to 2, we're going to have a radius of 4, so pi 4 squared. And we're going to subtract our inner one, and our inner one is going to be y equals x squared. So that's going to be pi x squared squared. All of this dx. Now, as a reminder, I'm going to go ahead and show you how to evaluate this integral by typing into your calculator. But after this, I'm going to go ahead and expect that you know how to do this. So we'll go to math. We'll go to 9 to do our integral, and we are going to type in from 0 to 2 of pi. We're just going to leave pi out because pi is in both of them. So we're going to have 16, because it's 4 squared, minus x to the 4th dx. And then we're just going to multiply this by pi at the end. I could probably just not do the multiplication symbol, but whatever. And we get 80.4. So we have 80.424 units cubed. I want you to go ahead and pause the video and try this one yourself. You're rotating this one around the y-axis. And let me know how that goes. All right, I'm assuming that you've taken the time to do that one. So in order to not waste time, there you go. I did this one earlier. The time that I want to spend on is the other ones, because those are weird. So let's go ahead and talk about y equals -1. So if we talk about y equals -1, that is not just going to be this here. That is going to be one below. So let's draw that dotted line where there's going to be the axis of rotation, which means that our function is going to be mirrored down here instead. It still has a height of 4, so we're going to go all the way to 6, -6. So we're going to have this. And maybe just to make this a little more curved. Okay, so let's go ahead and draw our figure. This one's going to be a little bit weird to draw as well. Oh, I shouldn't have erased that one. That's fine. So what is our figure? Our figure is a cylinder with like a horn removed. So how are we going to find the volume of that? We are going to have horizontal slices, or sorry, vertical. They're going to be vertical slices. They're going to be vertical slices. A typical circle may look like this with a circle removed. So we are, once again, like the top one, going to be using the washer method. The way I like to think of this, though, is I like to take my graph and move it so that this is now going to be the x-axis. So what would be my graph if that was my x-axis? Instead of it being x equals negative or y equals -1, what if that was y equals 0? How would I produce this graph that is 1 above where it started? Well, I could just take our original function, which is y equals x squared, and I can add 1 to it. So this blue part here, this top part here, is the same thing as y equals x squared plus 1. And then we are just going to pretend that our graph actually isn't moved at all. So since this is y equals x squared plus 1, where's it going to cross? It's not going to cross at y equals 4 anymore. Our y equals 4 is going to have to be moved up at 1 as well. So it's going to cross y equals 5. So we are now going to integrate from 0 to 2 because that's our total height there of our cylinders. So we're going to go from 0 to 2. And we're going to do our two equations. Now our radius is going to be 5. So we're going to do pi r squared, so 5 squared. And we're going to subtract our inner function. So our inner function is going to be pi x squared plus 1 squared. And all of this is dx. And I did this one earlier, so I'm just going to go ahead and bring our integral up, and we should get, you should definitely type this in yourself in your graphing calculator to confirm, and you get 113.9 units cubed. Let's look at our last one. This is x equals 3. This one's going to be even stranger. So x equals 3 is this graph here. If I was to rotate around that, just to get a more accurate picture of what we're going to do, is I'm going to draw this and I'm going to mirror it over. So let's go ahead and rotate this. We're going to flip vertically or horizontally, I mean. And put it right there. That looks good. So let's draw our typical figure if we were to rotate this around this way. So let's go ahead and figure out what is going on. Once again, like the previous one, we end up having a big cylinder with a horn removed. So once again, we're going to be using the washer method. I'm going to make this big actually, since we don't need the calculator anymore. So now the question we need to ask ourselves is, how do we get either this one or this one? Like, which one is going to be easier for us to get? We need to get this function, which is going to be shifted over. We're going to get this function, which is, let me see here, confusing myself. Oops. So if this was our y-axis, how would I get this function? Well, this function is just going to be y equals x squared, but it's going to be shifted over to the left 3. So how are we going to take y equals x squared and shift it to the left 3? We're going to add 3. So y equals x plus 3 squared. We are still going to have the same height, so we're going to have y equals 4. That's going to be our other function. That's going to be how many slices or how tall our slices are going to be, or our integral. We're going to be doing dy though this time, so we need to rewrite our y equals x plus 3 squared as in terms of x instead. So we'll go ahead and take the square root of y, so the square root of y, and then we'll subtract 3 equals x. So that's going to be our inside function. That's going to be this one, inside function, all of these inside ones. And then our outside one is just going to be a radius of 3, it looks like. So we have an integral from 0 to 4, because that's our height, of pi r squared. And our radius this time is going to be 3. That's going to be our large one. So pi 3 squared minus pi the square root of y minus 3 squared, and all of this dy, which I did earlier. So here we go. We have 75.39 units cubed. Okay, so your homework is just going to be one problem. It's essentially just the same thing as these four, but with a different example. Let me know if you have questions later.